So before we get started, I want to introduce myself really quick. So my name is Jose Chinchilla. I am the Director of Data Analytics at Agile, where I lead our team members in our analytics practice, which now we formally rebranded our practice as the Insights practice, which includes not only data engineering, data analytics, but also data science, machine learning, and AI. And I work closely with our principal data scientist and our global managing director to bring data analytics, machine learning, AI to our customers, make sure that we deliver with the best outcomes possible. So I'm also a author or co-author of several books, including the latest exam reference book for implementing a data warehouse, which is the official courseware book for exam 7-767 from the Microsoft courseware. In addition to that, I've co-authored books specializing, focusing on SQL Server administration and SQL Server development. One of the books was the SQL Server 2012 Bible book. So that makes me a disciple of a SQL Server. In addition to that, I hold several certifications, including MCSE, MCSA, and the latest one, which is the Microsoft Certified Trainer certification. So at Agile, we not only do software development or consulting, we also do training, and you can find a lot of our training offerings on our website at agilethought.com. And some of those relate to data analytics, Power BI, data cloud migrations, and some other business information type of training. So in this workshop, we'll cover a wide breadth of cloud analytics capabilities, mainly, of course, in the Azure cloud platform. And specifically, we're going to be talking about what the Azure Synapse service brings to the table. As you may know, or you may already heard or read somewhere, Azure Synapse Analytics is the latest iteration of a unified analytics platform that Microsoft has made available in the Azure cloud. So today, I'll try to teach you or show you how to create an analytics pipeline that goes from data ingestion to business intelligence, enabling self-service BI, self-service analytics, and really help you understand how can these technologies allow your business to become a truly data-driven organization, a truly data-driven culture within your organization. And so later in the workshop, what I'll do is I'll walk you through a hands-on training and hands-on labs that will actually show you how to get started and give you some of the initial learning, initial understanding of how Azure Synapse works and what are the different services, technologies that make up the new Azure Synapse Analytics offering from Microsoft. So we are going to have some slides that we're going to go through just to understand where and why Microsoft came up with this unified, bundled type of service. And then we're going to talk about specifically about Azure Synapse Analytics and the different components that make up Synapse. And then, give you some ideas and some information on how can you get started with your first analytics projects. So we're going to talk about some accelerators that are available by Microsoft and also some data sets that you can start working with. If you don't have data available already in the cloud, you can use some sample data that really good sample data, by the way, that Microsoft makes available just to understand how Synapse works. And then we're going to do a hands-on lab. So everybody is going to get access to a Azure services, Azure Synapse, and some pre-configured environment that you will be able to actually do some development and follow me on this hands-on lab. We will send that information right around 1 p.m. because those are environments that are made available, at the right moment, the right time by Microsoft. So it's not available right now. That will be on until like 1 p.m., which is where we think we're going to be start talking about the hands-on lab. Along the way, we're going to take several breaks. Some of them will be quick, 5-minute, 10-minute breaks, just to stretch, stand up, take a bio break, get some water, coffee. But we're going to take a good break before the hands-on lab to allow you to prepare for the lab, get some lunch. I personally am in the Eastern time zone, so we're going to be delivering this workshop through our lunchtime here in the Eastern side. But those of you joining from other time zones, might be a early lunch or maybe late breakfast. So with that said, let me get started. And I want to just make a quick plug about our Accelerate Summit that is coming up February 25th. As you can see in my background, we are going to be delivering a series of conversations, series of chats, fireside chats about several topics, agile transformation, about data analytics, AI, ML, and some of the great conversations like women in technology is a great conversation that you might want to attend. Either you're a technical or business person, that's always a good conversation to have inclusion. And in particularly, I have highlighted a AI panel that I will be facilitating called the 3 Must Knows When Implementing Artificial Intelligence. We have a wide variety of panelists from all different walks of life and different type of backgrounds. In organizations, in retail, manufacturing, professional services, and as well as government. So it will be very insightful to hear from them as they can bring to the table some of the topics, some of the themes that are happening on their side in different walks of life. So it's important if you are interested in starting your AI journey in your organization, or even if you already started. It seems like, let me see, make sure that we have, haven't been sharing or the right slide. So let me actually get that going. Apologies for that. And let me share. Give me 1 second. All right, can you see? Oh, there we go. I see the issue now. Okay, so apologies. It seems like it is sharing the wrong screen. And now let me share the correct content. 1 second. All right, you should be seeing the agenda right now. Yes, okay, excellent. So yeah, so this was the agenda that I was walking you through, and then the Accelerate Summit that we will be hosting February 25th. There's a link in the slides that maybe some of our team members that are supporting me today on this workshop can put in the Q&A section so that you can have it. So feel free to register and attend. It's going to be really insightful. All right, so with that said, let's start talking about some of the concepts around data analytics, some of the challenges that most organizations are facing. So the reason we're here, and most of you are here, is because your business collects data, right? And we believe that all businesses essentially are data businesses. But that means different things to different organizations. So one of them is what does the data mean for business, and what does the analytics that surround that data, what the analytics can do for a business, right? Also, how can the cloud enable some of those capabilities to get better insights about your business and about the data that your business collects. And we know historically, traditionally, there has been some type of tension and challenge around the traditional approach to data analytics. And also just an understanding of how, what the ideal state or end state for analytics looks like, right? Does analytics involve just a bunch of reports, a bunch of dashboards? Does analytic mean empowering your business users in addition to your technical users to be able to analyze the data? And what are the tools, what is the tooling that should be used? What is the format of the data that we should be using? So with that said, let's again define that all businesses are data businesses. A lot of topics and a lot of conversations around that the new currency is data, right? That the new oil is data. And every business collects data, every business generates data, and that is what empowers a lot of business decisions, right? So over the years, we've seen that digital transformation across many different industries and different regions around the world. Some of these transformations have been disruptive due to situations like the COVID pandemic that we're experiencing still and throughout 2020 and still in 2021. That has forced a lot of organizations to transform digitally, right? And essentially put a lot of effort and work towards that digital transformation. In that same element, right, that is at the heart of that digital transformation, vis-a-vis data, is also the challenge that organizations are facing and how to be able to adapt quickly, be able to respond to market, to the market, and be able to be proactive and be able to have services offerings or tailor products and services to a changing market, right? So what empowers that transformation, what empowers those decisions is essentially data, in the analytical power that an organization has around data. Be able to gain new insights, be able to predict customer behaviors, and essentially be able to plan ahead of time. So, data is not just about knowing what happened in the past. It is also what will happen or is happening in real time in your business. So this is why this conversation is really important, and this is why platforms and services like Azure Synapse is very relevant now to be able to respond to these changes and disruptions in the market. But in addition to that, we need to, in a way, to do this in a secure way, right? We need to be able to make this data and these tools available, and this analytical power available to our business users, technical users, with the right governance and security and accountability. So this is some of the challenges that organizations are facing. How do you do that? How do you respond to disruptions fast? How do you respond to market conditions quick? How do you proactively understand what will happen, right, in the next months, a couple quarters, and to do this in a secure way? So So of course, the challenge is that you're gonna be not only generating more data and wanting to make decisions based on this data, but what makes these challenges and these services relevant to this point. So we know for a fact that dashboards and reports will be at the heart of the business, right? And that allows us to understand what has happened or what is happening. Visualizations with business intelligence and analytics with reporting tools like Power BI, for example, allow us to strengthen the role of the knowledge workers and be able to have informed insights to recommend, suggest changes in support decisions. And then that with the augmented intelligence, we can discover information and patterns that even your subject matter experts, even your business knowledge workers may overlook. So all of these capabilities are really, really relevant. Be able to extend the current capabilities of business intelligence and analytics with more of this augmented intelligence. Thinking about machine learning and AI and some of these other more innovative ways of discovering patterns in our data. So while data analytics is important, it is really increasingly evident that not all analytics are equal, right? Data science takes that traditional analytics to the next level because it enables automated insights at a depth and scale that's beyond the abilities of any human is capable, all right? And it really allows us, it allows businesses to understand their data better and faster than even before. Using machine learning in artificial intelligence, for example, helps drive that autonomous processes, autonomous learning, and decision making so that organizations can respond more intelligently, more efficiently. But in order to achieve that level of automation, businesses need a scalable solution that allows them to implement these technologies faster and more efficiently, and not get them stuck in the business of managing technology, right? In the business of setting up servers, maintaining servers, in configuring all these different services. That's why the cloud makes this possible for organizations to move ahead faster, quicker, and without the growing pains of having to set up a lot of infrastructure and a lot of capital investments for this to happen. And as you have seen it, and most of you hopefully have already seen, if you already have a cloud strategy or are already in the cloud, it really enables you to start and scale projects easier and faster than any on-premises type of solution. It is now is considered now the default environment for new technology initiatives because it allows you to essentially click a few buttons and you can get services and up and running without all the overhead of getting infrastructure provision, budgeting for the infrastructure, provisioning the infrastructure, and then waiting on IT, right, to have that up and running. Now you can enable that through the cloud. And it also, one aspect that we've seen with our clients in particular is a kind of like a hybrid approach where they have some core functionality on premises, but they have like a sandbox environment or a POC, POV environment in the cloud that they can quickly stand up, provide or show the business value, and either take some of that capabilities back onto their on-premises infrastructure, or they simply realize that, hey, it's cheaper, faster, better, more efficiently to do it in the cloud, and they just make that proof of value into a production environment in the cloud. So that's something that has worked a lot with our customers, and I think that is a good strategy going forward to be able to put those initial assets, those initial initiatives in the cloud. So cloud-based analytic platforms, we know, and already said, eliminate the need for a lot of those capital or CapEx investments. It's quicker to deploy in the cloud, easier, more flexible. It allows you to get started without having to put a lot of planning on the scalability, because with the cloud you can scale as you later discover, right? But one thing that is also important is not only if you perhaps did not plan or anticipated a high volume or a higher amount of scalability and performance needs, you also have the reverse, right? If you find out that perhaps you didn't need as much, scalability as you initially thought, you can scale down. So now you can fine tune your budget to your needs, right? But be able to do it quickly, instead of having a bunch of servers sitting in your data center that either are not being used or are not enough to satisfy the workloads. So this is where the cloud is really great for those that fine tuning and proof of values that your organization might need. And then as the volume and variety of the data expands, some of these modern cloud-based data services can serve as the home for all of that data. As I mentioned, you may anticipate that you will be getting relational data, into your databases, perhaps CSV or some type of file format. But later down the road, you may get a lot of data in different formats, and that could be log, machine telemetry, that could be audio, videos, or even just like Word, Excel files that you need to ingest. So traditional approaches to data analytics may not work, and this is where the cloud really helps in services like Synapse that brings an ecosystem of different tools and services really help to be able to accommodate for data formats that you may not foreseen as a need in the future. So this creates a paradox of analytics, right? Which is considered the new paradox, because as you may have heard today, and you will hear toward the workshop today, and you've heard probably before, and you will hear, in the next couple of days, weeks, and months, is that you have a lot of choices and pretty much endless capabilities for analytics in the cloud. And you may be wondering if, all of those choices and capabilities make it actually harder to know everything you need to know to do everything that you want to do, right? So how do you choose the right platform? How do you choose the right vendor? How do you choose the right cloud? That sense of there's too many choices, there's too many things that I can do with so many different technologies, sometimes overwhelms decision makers and business owners of these solutions. And you're not wrong, and you're not alone in that feeling. Even ourselves as consultants, sometimes we need to balance what different platforms, different services bring to the table, and match that with our customer needs. So that is something that everybody goes through, and I think Microsoft has really has had an eye and ear on the market, right? Really understanding what are those needs, what are those challenges, and what are the things that they need to put into place to make that feeling of too many choices, too many things out there, a little bit easier to go through, right? And understand and make a better informed decision. So this is where the industry as a whole, not just Microsoft, but the industry as a whole, has evolved analytics to a point of a paradox, right? Or it looks like it looks like that. Right? So for instance, there's an ever-growing volume of data. You capture more data than ever before. Everything now seems to capture data here, from your business applications themselves to devices to our light bulbs, our phones. Everything now generates, captures, produces data. So there's a lot of data that's being generated and captured and ingested. And the industry analytics expects that this data growth will quadruple in 2025. So, and the issue with that is that, it's fine if you produce more data, you ingest more data. The problem is that in the reality is that based on some surveys and some understanding of the data analytics industry, about 20%, 27%, less than 30% of that data will be analyzed. Why? Because of technology limitations, because of budget limitations. So there has to be a different way of being able to analyze this data. So it's not really that businesses don't understand their data. They know perhaps, or have an idea of what their data might be telling them, or what the type of information that's in that data. But sometimes a lot of that is just simply ignored because there's no time, no people to be able to look at it and derive insights. So one conversation that Microsoft made available with the Fortune 1000 leaders is that although data analytics and machine learning, AI are their top of mind, top investment, data initiatives in these areas can be challenging from many different reasons. 80% of those 1,000 leaders said that they struggle to advance their data insights. They spend months or years until they see value out of their data analytics AI initiatives. More than half blame the challenges on data silos and governance management issues that essentially create roadblocks. And more than 0.5% also admit that they treat data as a business asset. Actually, they don't treat it as a business asset, and not because they don't think it's valuable, because it matters. They just don't have the processing capability. They understand that it's an asset, but they don't treat it as such. That just due to human limitations and technological limitations up to date, right? And that's where that paradox gets us. So the paradox makes us understand that part of the underlying problem has to do a lot with the way the industry has approached analytics up to date. For many decades, there has been a advent of specialized technologies and specialized patterns, including things like data warehouses and data lakes that handle very specific types of data that have helped us collect and analyze data, all sizes of shapes, formats, and volumes, right? But this, in a sense, increases the creation of more niche data, more silos themselves, right? And definitely, this has led to the ultimate paradox of analytics. We created all these technologies. We use many different technologies that are for different type of use cases, different type of workloads. But those technology implementations themselves have created yet another problem, yet another silo. And this is that ultimate paradox in analytics. We apply new technology to integrate and analyze data, And as we do that, we create more silos. So to harness the power of data, we definitely need to break down these silos without creating new ones and approach data analytics holistically, right? It is no longer BI for a division, BI for a work group. It is not self-service BI. It is not just reporting and enterprise reporting. It is not machine learning and AI as different silos. Now there has to be a new approach where all of this is unified, and this is where the new services, a new approach by Microsoft with Azure Synapse comes to play. How to bring all of that together and eliminate these silos from these different use cases and workloads. So on top of data warehouses and data lakes, organizations still need more technologies for visualizing, reporting, data science, and governance. So there's always going to be a need for newer and purpose-built technologies for this specific type of workloads and specifically type of audiences as well. So each new technology you adopt will create inherently another siloed operation, right? Another siloed audience, another siloed data set. And the task of connecting all of these systems, all of these processes together requires specialized skills, building out new policies, protocols, processes, and sometimes the need to duplicate the data again and again for these purpose-built solutions. But when you step back and consider this traditional approach to analytics of creating all these silos based on the technology, based on the workloads, building a new system for each new activity, makes sense at a time because, of the technological limitations or perhaps the skill set required for that, or even the audience for that type of solution. However, as the volume of the data and the complexity of all the systems continues to increase, adding more and more disparate technologies only compounds that problem of silos. So there comes to a point in which that complexity of adding another analytics technology, another analytics platform, outweighs the benefits of the technology itself. So we're compounding that problem as we add new technology. So definitely a more holistic approach is key to unlocking the analytics paradox because of the goal of the modern organizations in simplifying and democratizing data across the organization. So today it's common for decision makers to increase the traditional reports and dashboarding capabilities and to engage new sources and tools to incorporate new approaches to data, such as implementing big data technologies, implementing machine learning, or even AI. However, the more advanced the technology, again, the more siloed the data, but more importantly, the skill sets become. And it's really hard to understand the implication and understand the larger picture in here. So it is very common, and we've seen it with our customers, that when there's a new initiative, a new business solution that needs to get implemented, technology comes first. Of course, data comes in, then what technology is needed to be able to leverage that data. And then one of the last thoughts is, what skills do we need, right? We implement new technologies, we understand what data needs to be analyzed, but one of the pictures that's left out of the equation here is skill sets. So now you put the burden on your team members to either upskill as fast as possible, either through training or engage with partners that already have that skill set in-house and bring that to your organization. So now this is sort of the shift, right, in the way and the mentality that all of these thought leaders and industry leaders have provided feedback on. And that's why Microsoft took this new approach to analytics in Azure to enable this holistic experience of business insights and data analytics, taking into consideration the skill sets required for this. So Microsoft architected an operational and analytical data store to take full advantage of cloud-native architectures. And this is a fundamental shift in the way Microsoft has been doing things, because now it maintains that consistency in tools, programming languages, and it really enables to eliminate those silos of data and also those siloed skill sets that are required. So now decision makers can make better decisions and have better understanding of their data without incorporating new silos because of these initiatives. So at the core of this, as I mentioned, is the new service called Azure Synapse Analytics. And just a quick definition of what Azure Synapse Analytics is. It is a limitless analytics service that brings together data integration, enterprise data warehousing, big data analytics in a single service that allows you to bring quicker insights in your organization. So with Azure Synapse, organizations can run the entire breadth, entire full gamut of analytics projects, and put data to work much quicker, right? More securely and efficiently, and be able to provide your team members, your human resources, your developers, and most importantly, those subject matter experts, business analysts, data analysts, to access the data with the tooling that they are more comfortable with at the scale that they need. So it combines capabilities, spanning the need from data engineering, data scientists, ETL developers, like I mentioned, business analysts, or those power users, BI developers, to create new insights, new ways of interacting with the data in a much more efficient and scalable way without having to introduce a whole bunch of new technologies and processes that just get in the way, right? So there's several customers that have already adopted Azure Synapse, including Walgreens and Procter & Gamble, which we're going to hear some customer success stories in a little bit. And they have already achieved tremendous success with Azure Synapse, and they're able to move to more global, generally available solutions with their customers with a single unified platform, which is Azure Synapse Analytics. And we're going to walk through some of those customer success stories in a little bit. All right, so we're gonna dive a little bit deeper into Azure Synapse Analytics. I'm gonna go through the process of describing the different components, the different technologies that make up Azure Synapse Analytics. And but we're gonna take a quick break. It's gonna be just a 5-minute break, so you can stretch a little bit, get some coffee. And then we're gonna dive a little bit deeper into Azure Synapse Analytics. Also, I'm gonna take the time to look at some of the questions that you may have posted and try to answer those or address those as needed. So feel free to add some of those questions in the Q&A section if you haven't done so. So we're gonna take a quick break and go from there. All right, so we're coming down to our 5-minute break, and there has been some good questions so far. So I am going to address a very important question about how to scale logically, both in cost, I guess, and in performance, without breaking the bank, right? So let me address that really quick. So with Azure Synapse Analytics in particular, that is one of the make sure that I'm sharing. That's one of the key reasons why the Azure Synapse Analytics service or platform, if you want to call it, was created. Being able to allow organizations to put their solutions in the cloud, take advantage of these innovative technologies that allow you to analyze big data, volumes of data, or variety of data in a in a way that it will perform and scale, but also that it will not break your budget. So there's many ways, and I'm going to talk about this in a little bit. There's many approaches or strategies to do this, right? So one of the things that I always emphasize, and I like this quote from a colleague from in Microsoft that mentioned this in a recent meeting, was start small, right? But the key thing is to start, right? Perhaps you don't bring the entire data set, you bring a subset of the data set. Second is start small also in terms of the size of your or tiers of your services, and either scale up or scale out once you have a good understanding of what are going to be those requirements for your data set. The great thing about Azure, and if you're not aware, there's an Azure pricing calculator that you can take advantage. And I think let me see if that comes through in, yeah. So there's a Azure pricing calculator where you can essentially add, services to essentially like a recipe that you plan to build. And you can also add here how many hours, days, or months you think that service will be up, how big you need that resource available. And that will give you an idea of what is your maximum limit in terms of budget and cost, but also an understanding of some of these services can be turned off or paused while you don't need them. So that's one tip that I'll give you. Just use the pricing calculator to kind of create a budget, but also to be able to give you an understanding of how much you can scale those services, and perhaps where you need those services to scale, or in what the timing of those services to scale. And again, as you will see in a little bit in our presentation, you have the ability to not only scale up those resources, but also scale out and be able to distribute and have other features such as high availability and high concurrency when you set up these services. So a great question, and we can chat a little bit more about that after the workshop or during the workshop in the Q&A portion of it. So with that said, Azure Synapse provides a unified experience that brings all of these together, right? All these capabilities together, from data ingestion, big data analytics, data warehousing, data lake, at a cloud scale. Like I mentioned, be able to scale up, but scale out. But most importantly, like I mentioned, not only scale up and scale out, it's also the ability to scale down when you don't need those services. And this is the biggest value added that the cloud, Azure, and Synapse in particular brings to the table. That is also something that's missing in the strategy, that there are some major cost savings by managing and throttling those services as needed, right? that is something that has enlightened a lot of our customers, where they didn't have that as part of the strategy. They always budgeted for a certain amount of services 24/7, but they really don't need a lot of these services to be 24/7. Or perhaps we have helped them understand the seasonality of the demand on their services, and that has helped them tailor and proactively scale up, scale down those services as needed. And then also taking into consideration the end user or your customer experience, right? And taking advantage of regional available services and standing up perhaps more services during peak times in those regions where those services are needed. So balancing all of this is key to have a good strategy, not only to scale in terms of performance, in terms of user experience, but also in terms of budgeting, which is at the core of every solution, every organization, being able to manage that. So Synapse Analytics brings all of this together, right? The data ingestion, data orchestration, the big data analytics, and of course, the way you store your data, that being said, being a data warehouse, being a data lake, or what is now happening, which is a merge between a data warehouse and a data lake, sometimes referred to as like a data lake house, which I think Databricks came up with that term, but it's now being implemented as part of a open source technology or open source pattern called the Delta Lake, right? Which Databricks, Synapse Analytics incorporates in it. So Synapse Analytics really helps you bring together all these services without creating additional silos, and really unifies data, tasks, activities, and skills in a really limitless analytics service in Azure. It also simplifies not just the development of this solution, but it also simplifies the sometimes monotonous but necessary chores that accompany every data solution. And that is securing your data pipelines, assigning permissions, creating firewalls, and putting all these controls and guards around your data, because as we have heard and we've seen many examples of hacking and data breach issues, security has to be top of mind with any type of solution that's in the cloud, or even if it's on-premise. But Synapse Analytics brings all that and incorporates all that. So security is not an afterthought. Security is part of the strategy in the creation of Synapse Analytics. So with that said, within Synapse, you have a whole new development environment. Some of you may be already familiarized with this development environment, and I'm going to talk about that. And that environment in Synapse is called Synapse Studio. And this is where the Microsoft Azure team has done a really great job by simplifying the development experience and the management experience of these data assets and services, and really simplified it with Azure Synapse. This is something that I really love about Synapse, because it's a consolidated environment that is very user friendly, and you will see that during our lab environment and throughout the presentation in some screenshots. So at the core of Synapse is a very innovative technology, which is essentially a distributed SQL engine that powers Azure Synapse. And with Synapse, you also get, not only the SQL distributed engine, but you also get some of the big data technology that are predominant nowadays for any type of big data workload, including Apache Spark. So SQL distributed engine and Apache Spark work together to be able to scale your workloads, but most importantly, be able to apply the right engine and use the right engine for the workload that you need to run your data analytics on, right? So you're not constrained to a relational database engine. You're not constrained to a Hadoop or in-memory type of engine. You can take advantage of both where it makes more sense to use it, and it's really allowing you to create that limitless scale, right, on both structured and unstructured or semi-structured data, and using the right engine for that type of workload. So the result of all this architecting and fine-tuning of using the right engine, technologies, and services is what the new cloud-native distributed SQL engine that powers Azure Synapse is all about. With very deep integrations with Spark and SQL engines, Azure Synapse is enabling a level of collaboration among data professionals that previously wasn't possible, right? So many of you, as we talk, and as we talk about silos, typically it's the data engineering team, the data warehouse team handing off data to the data scientists, and then they bring in that data and applying other technologies and applying other development environments to it. Mainly notebooks, for example, Jupyter notebooks, and then the data engineers, the data architects working behind the scenes on the data lake and data warehouse probably use Management Studio, probably use Data Factory or SSIS or some other type of ETL tool. So those toolings beforehand were not unified, were not even compatible, right? They were totally different IDEs or development environments. And this is where now Azure Synapse with Azure Synapse Studio brings to the table, along with the engines that power these different development experiences. So now, with that said, and as we talk about the strategy, not only in budget and cost, but also in scalability, performance, and user experience, it's really nice to have a choice, right? How do you allocate and consume the resources as well? So for example, in Azure Synapse, you can take advantage of two types of resource models. One of them is the serverless resource model, and the other one is the dedicated resource model. And essentially what this is if you have very predictable performance and cost requirements, you can take advantage of the dedicated SQL pools, dedicated resources that you know are going to consume X amount of compute hours, of storage perhaps, and you have a more predictable cost, right? Because you know exactly how much it's going to cost to have that service running for the next 6 months, the next year or so. So this is where the dedicated capacity comes in, because now you have a very predictable cost, but also a very predictable performance experience. Now, on the other side, when you don't have a good understanding of what your cost will look like, a good understanding of what your performance requirements will be, then there's the other resource model called the serverless resource model. And this is part of that strategy that I was talking about, because serverless architecture allows you to define the services that you need with the understanding that those services will not always be, will have a consistent performance perhaps, but you will be able to set criteria like throttling or scalability configurations to allow you to get that performance burst on demand. So while not having servers spinning, not being used, those serverless services will essentially be deallocated, and when that workload ramps up, then those services come up online, and burst or scale as those workloads require. And that bursting capability is what makes the cost effectiveness of a serverless architecture very, very enticing for a lot of our customers. And again, you don't have to make a lot of capital investment upfront and just have servers consuming power and just spinning disks, or if you have spinning disks, is still, but just up and running and consuming power for no reason, right? You can allocate them and burst on demand as the workload is needed. So this is a very interesting value proposition and very interesting strategy for a lot of organizations that don't have that predictable cost, those predictable SLAs. A serverless architecture really allows you to define your architecture, get started with your data solution, your analytic solution, and grow as needed and understand where your limits should be. So if you so decide, then you can turn those serverless services into dedicated resource pools that now you have a fixed cost and fixed SLAs around those services. And this is where we see a lot of our customers, which we're doing some POCs or POVs, proof of concept, proof of values with Synapse, really find most of the value of what Synapse brings to the table, what the value proposition of Synapse. It's really that compute capacity and performance discovery phase when you have that unpredictable SLAs in your solution, right? But for those that are more mature in your analytics journey, dedicated pools perhaps make more sense because you know exactly what your capacity is and what it should be when you move your workloads into an Azure Synapse Analytics service. So it caters to both, right? Those that are just starting, don't know where to start, how to start, and those who already have a more mature understanding of their solution and just need to have that predictable workload performance and SLA. So now let's dive deeper into Azure Synapse, and I'm going to talk about how all of this comes together, the different components, like I mentioned, that help you be more efficient and optimize your analytics solutions. So first of all, start with what is top of mind on many data architects and security officers out there, and that is how can you secure and make sure that you are in compliance with services like Synapse. So in that quest to break down the silos and be able to empower all of your users and be able to access that continuum of data analytics, that question of governance and security really is relevant, right? And Azure Synapse Analytics really challenges the role of your IT department or your IT team members and the role that they play by providing this well-managed set of tools and services that support your organization's policies, procedures, and industry best practices among your business users and your developers. And one of the ways that Synapse does that is by building data protection into the core, right, into the fabric of all of these services. And with Synapse, you get a comprehensive approach to security. So everything from access and authentication to proactive threat protection and compliance. And this is really something that has not been perhaps understood or perhaps marketed until now. And that is that proactive threat protection and compliance. And Azure has some services that allow you to do that we're going to talk on the next couple slides, to be able to proactively classify and identify those data sets that need special protection, and also those areas in your architecture that need protection, through firewalls, through more access control, data masking, perhaps, and some of all or data tokenization for those in PHI and PCI type of environments. And because Azure, all of this is based on Azure, right? You get all the latest updates and latest features that Microsoft Azure rolls out. So you don't need to be on top of all of these new features, and you can really just take a little bit of a hands-off approach and allow Azure to manage a lot of this proactively for you. Of course, there has to be some oversight, some maintenance or management. Make sure that all the new features are enabled and are securing the data that complies with your procedures, right? So pretty much everything, from data protection, right, to access control, authentication, network security, threat protection, and isolation of those services and data sets is built into Azure Synapse. And in terms of, for example, configuration management, they manage a lot of the infrastructure behind the scenes, especially all the virtual networks and firewall rules and policies that connect your data pool seamlessly in compliance with all the different services, and with the team members in mind, so that they don't have to to do specialized configurations, setup, and maintenance. All of this is handled for you behind the scenes. A lot of this is already well documented, so you understand how they're doing it. And but it really allows your IT department, your IT team members, and your end users to not have to worry a lot about configuring and setting things up. All of this is configured securely for you, and you can always add additional security policies and additional security configurations. But for the most part, all of this is built in with Azure Synapse. So talking about data governance and how these data governance policies are applied proactively for you, this is done with a service called Azure Purview. So if you have not read or come up to speed with Azure Purview, I encourage you to do so. Azure Purview really allows you to apply your own data governance policies along with industry standard and best practices governance policies that are already built in within Azure Purview. And Azure Purview is part of this native integration with Azure Synapse. And it automatically, discovers, classifies data assets based on what you set up, based on also on best practices and industry standards. And it gives you that end-to-end protection, end-to-end data lineage tracking in your entire life cycle of your data solution. So Data Purview, really integral part of Synapse that I think you should look into and dive deeper as you learn and you grow in your Synapse journey. So that brings me to a very interesting customer success story that Microsoft made available, and you can read this on their website. But there's an organization called Grab that is in the delivery in payments services that they had very interesting challenges around a globally distributed customer base. And also compliance requirements, because of that distributed customer base, where they had to make sure that they comply with data governance, data sovereignty, data residency requirements. At the same time, enabling them to do analytics on top of this data while being compliant and while securing this data. And this is one of the first companies out there that adopted Synapse and had a very, very successful implementation, because it allowed them to apply governance and apply security on their data while allowing their data engineers, data scientists to carry out their analytics activities while remaining in compliance. So very interesting customer success stories that you can go read online a little bit more in detail, and it highlights how Synapse really helps organizations with this type of challenges, which, by the way, a lot of organizations have. So it's not just globally distributed organization. There's also organizations in the US or within Europe that really can take advantage of this. So in addition to data governance and security, a core component of every data analytics solution is the ability to integrate data from all these different silos, right? We already talked about line of business applications that create silos, specialized or purpose-built data solutions that create silos. So that is the case for many organizations right now. So the only way to accommodate for that is to integrate that data together, but doing it without adding additional complexity and additional silos, both technological and both skill sets. So how do you do that? How do you connect all this data? So with Synapse, the Synapse approach is essentially a code-free or low-code, no-code type of approach. So your experienced users with a lot of SQL knowledge, with a lot of Python knowledge, Scala knowledge, Spark type of big data type of programming language, or even C# now, can really leverage Synapse Analytics in the Synapse environment without having to learn a new programming skill. And this is where Azure Synapse employs sort of like a hybrid approach to data integration, putting together pretty much everything that your users need, your developers need to bring data together from different data sources. So whether you prefer to do, your users or developers, your data engineers, or data scientists prefer to code yourself, or for those that perhaps don't have all the skill sets, programming skill sets yet, there's also a low-code, no-code interface where you can essentially point and click, create data pipelines, create schedules, or even create event-based automated triggers to keep your data current and bring your data together, right? And a lot of you may have seen this interface. It might be familiar with this. And this is an Excel-like user experience. This is called, in other Microsoft products, Microsoft technologies, called Power Query. And you see this same Power Query experience in Excel. So your data analysts, your business analysts, power users may already be familiarized with this development environment that is built in Excel, and that is called Power Query. Typically, you will interface with Power Query in Excel by clicking on the Get Data or in the Data section of Excel. And for those of you who may not be aware, essentially, this is Power Query. And this is the same development environment that is available in Excel, like I mentioned, Power BI, Analysis Services, and now it's also available in Synapse Analytics. So this really is a great story, right? In the part of this continuum of analytics where users that already have that experience and that familiarity with this Excel-like, tabular way of prepping your data, transforming your data, they can carry on with those skills in Synapse Analytics. And this is one of the greatest, I think, success stories that Microsoft has had with Power BI in bridging that gap of the skill set required to create really stunning visualizations with the same skill sets that your data analyst, business analysts already are familiarized with in Excel. And really powerful story here that I think will help with that strategy of implementing Synapse in this new paradox in analytics in your organization. So in addition to that, not only we're talking not only just being able to bring data in batch processing, kind of in a scheduled type of approach, but you can also take advantage of some of the other services that are built into Synapse that allow you to do more real-time analytics. So, for example, if you're consuming data from, every 5 minutes from your transactional systems that is being updated into your analytic systems, or if you are reading telemetry data, perhaps IoT device data, machine generated data, then you can also take advantage of the services that are bundled within Azure Synapse to be able to process that data and with sub-second or not sub-second, sub-minute, typically the 99th percentile per Microsoft benchmarks is within 90 seconds in the 99th percentile can be brought in, with really essentially real time with minimized latency. And again, some of you may be familiarized with the screenshot that you see here. And that is essentially Data Factory behind the scenes, right? So now you got Power Query, you got Data Factory, all within the same development environment that you can take advantage of. Whatever the use case is, whatever the type of workload is, whatever the skill set is, that is the story that Synapse Analytics brings to the table, right? Is choose your experience essentially in your development, but most importantly, choose the right service, the right tool for the right type of workload based on scalability, performance, and experience, right? So that is really a great story that Microsoft is painting with the Synapse Analytics offering. So let's take a look at some of the data warehouse functionality that Synapse Analytics has to support typical workloads like SQL workloads, right? Which probably most every organization has right now. And so it used to be that, for example, data warehouses was a enterprise level decision, a lot of planning, a lot of strategy around how your enterprise data warehouse should be built, what type of data set, what type of governance, what type of format and schemas that need to be put into place, right, as part of that enterprise data warehouse solution. And that usually has taken months, if not years, or even decades for some organizations. I mean, we still see customers seeking out for our support, our thought leadership, architecture, solutioning, and visioning, even when they already have an enterprise data warehouse that has been in place for 5, 6, 10 years, because they've reached a inflection point where it is not either scaling or it's not meeting their needs. So they need a different lens and a different paradigm to how they approach data analytics. So with Synapse Analytics, you can not only leverage your traditional SQL-based, relational-based enterprise data warehouses. Now you can take advantage of more elastic platforms in Azure. For example, the data lake storage, data lake analytics generation, data lake storage generation tool, which is truly a limitless, very scalable storage solution for those workloads that don't necessarily fit into a relational schema approach. And all of these, again, now you don't have to manage that individually. Now that is an essential part of Azure Synapse. The relational endpoint, your semi-structured or unstructured data endpoint in a data lake, perhaps, all of that now comes together in a single development and management experience. So now you can scale from gigabytes to petabytes of data and even more, right? As we can see, or we'll see in some customer success stories, multi-petabyte elasticity that some of these customers have achieved so far. So, so we talk about that unified development experience, and particularly we talk about Synapse Studio. So what I have shown you so far is Synapse Studio, and I've shown you how the Excel-like development environment, Power Query type of environment, your more Data Factory, ETL, data integration environment. But we also have, as you can see in this screenshot in Synapse Studio, the same familiarized way of interfacing with relational type of workloads, right? Where you can essentially issue SQL scripts, everything again within that same Synapse, Azure Synapse Studio environment. So this is a very interesting proposition, because now you have a unified workspace for your data engineers, ETL developers, your business analysts, data analysts, as well as your database administrators, your data architects, to come together into a single unified development experience that gives you capabilities from code, a very familiarized code type of programming language, coding type of environment, such as like Visual Studio or SQL Server Management Studio, to more code-free type of interfaces like we saw with Power Query and Data Factory. So it's truly essentially an interface for everyone, right? And Synapse Studio, as you will see in the labs, is a web-native experience that ties everything together in a single location. So you don't have to install applications in everybody's laptop. You don't have to make licensing available for everything. Everything is bundled in this web-based development environment that is truly a holistic development environment in a web-based solution, right? So, so how does this compare to other vendors out there, other cloud platforms out there? So Microsoft made available this study, this research and benchmark study made by an organization called GigaOM, and they made two type of studies, right, or performance benchmarks. One of them is called the TPC-H, and the other or Test-H benchmark report, and the Test-DS benchmark report. And these reports allows you to level set, the criteria, the scalability, performance criteria, and standardize these benchmarks across different cloud platforms, across different services, and put them head to head, how they compare. And as part of this distributed relational engine and specialized engine that powers Synapse, which some of you may know as the Azure SQL Data Warehouse. That was the previous name or the initial incarnation of Azure Synapse, now branded as Azure Synapse instead of Azure SQL Data Warehouse. And the use of this specialized distributed engine called the Polaris engine has allowed Microsoft to outperform a lot of the other cloud platforms and other other analytics vendors out there. And this is all documented in a research study or benchmark report made by the organization I mentioned, and it just lets you know, and highlights how Azure Synapse has outperformed AWS, outperformed Google, and some of these other cloud analytics platforms that you may be using or may be planning to use. And also not only the ability to scale to petabyte scale, or but also be able to do that in a cost-effective way, and really demonstrated not only performance, like I said, but also price performance compared to other platforms that are commonly used, like the AWS Redshift, Teradata, and some analytic services in Google Cloud like BigQuery and some of these other specialized technologies. Now, not only it has outperformed them in terms of performance, in terms of cost, but also in the user experience, which is, I think, the underlying value added that needs to be highlighted, right? That yes, BigQuery, yes, Redshift can be used, and you may have success, but now those have become silos again, and this is where that paradox change, right? Paradigm shift is where, yes, we understand that the market has used these services traditionally because they have shown scalability and performance benefits, but they have created silos. So now Microsoft has made all of these capabilities available with Synapse, not only outperform those services and platforms in terms of cost and performance, but also in the user experience, in being able to unify all this in a single service that your organization can manage. And I think that is the biggest story out of it is, yep, Azure Synapse can beat competitors, cost and scalability. But it's also beating competitors in the user experience. And that is part of the key takeaway here that I think you will also experience yourself during our lab portion. So with that said, one of the conversations, one of the questions was around what is the strategy to be able to implement a data analytics solution such as Azure Synapse without knowing ahead of time how much performance, how much elasticity you need, and what is perhaps the cost associated with that. And this is where there's several strategies. We talk about serverless computing, dedicated pools, dedicated services, but also the ability to scale up, scale down, and scale out as needed. And the message here is that you can use this throttling and scale approach to give you that predictable cost and the predictable SLAs that you may require now or you may require in the future, right? So it means that you're not pigeonholed to a set of services, a set of compute or storage capability. When you start, you can start small, like I mentioned, and then grow as you need. But most importantly, grow as you need and grow up as you need, and then be able to scale down when you don't need that, right? So I know, for example, in a particular case of a client that is in the tax advisory space, of course, beginning of the year to probably April to June, May or June timeframe, the first half of the year, they require a lot of storage, a lot of compute process in their tax and auditing platforms, because that is the height of the tax season, right? And and towards the later half, the second half of the year, they don't need as much. So we were able to implement for them a scalable solution during the high peak usage, and then scale down solution during their slower season. And that is where Azure Synapse Analytics really helps manage and predict those costs as well. So a good example also here that is made available by Microsoft is the ABN AMRO organization. They had a very expensive Teradata system that was essentially running their budget out of whack, right? Because each year they needed to increase their Teradata footprint as their growth as they grew. And also, I think they made some acquisitions along the way that they had not foreseen, and now they have a bottleneck, right, within their Teradata system. So this was going to cost them a lot of money in the next couple of years. And they were also looking to do this in a secure way, as they were bringing more financial information and more sensitive information into their analytics platform. And they were able to accomplish this, saving about 70% of their previous costs and their budgeted costs in the next 3 to 5 years by implementing Azure Synapse Analytics, making use of the data security and data management services that are already built in, and the ability to scale up and scale down approach, right? So this is something very interesting, how a case study or a customer success story that Microsoft has made available that you can also read a little bit in more detail on their website. And I think that highlights the value proposition of Synapse versus some other cloud platforms and services. So, so we talked about a little bit about real-time operational analytics, right? And the key word here is operational. So we talk about real-time analytics with some of those data streaming data sets, like I mentioned, IoT devices, machine telemetry, for example, if you're manufacturing, consuming that machine telemetry from your manufacturing floor, and understanding what's happening, understanding the rate of the defects, and so forth, right? But there's also another use case in another specialized implementation of a new technology that Microsoft has made available in Synapse to also take advantage of your operational transactional systems. So many of you, for example, in retail, you have sales transactions, you have line of business applications that are constantly collecting data, constantly logging or recording transactions in those systems. And the typical approach has been sort of like a batch approach, right? Where you are bringing the new inserted updated data into your data analytics, data warehouse, data lake solution, through ETL toolings, or perhaps, doing some more real-time analytics and just having like a data pipeline, streaming data across. But the issue there is that twofold, right? One is the latency around that approach. You don't get what's happening, now. You get what happened in the last 5 minutes, in the last hour, the last day. And the other situation is the workload, the performance hit that you put on this relational operational system, right? For example, you have a SQL database, MySQL database, having to write data at the same time you're trying to read from it, make things, tend to make things a little bit slower, depending on how you architect your databases and your applications. But that is something that is particularly important for organizations that have a lot of legacy operational systems out there, that you cannot make those type of architectural changes easily, right? So this is where Synapse Analytics has created a new approach, and that is the approach of a hybrid transactional / analytics processing technology. And this technology is what they're naming as their Azure Synapse Link. And essentially, Azure Synapse Links allows you to click a button, say, I want to create a Synapse link between this operational database and my analytical solution, and be able to query that data in real time, efficiently, and without putting a lot of performance hit on that operational system. So this is where Azure Synapse again creates all of these configuration and create all of these technology behind the scenes for you in the form of that Azure Synapse link, and puts that operational data in a more efficient format to be able to read it faster and be able to get the updates of that operational database system faster and quicker in your analytical solution. So now you're be able to query your operational store, your operational databases, transactional database systems, almost immediately, right? Or I'll say it's, in less than 90 seconds, be able to understand what's happening now in those transactional systems that most cases might be legacy systems, and you can have that right away in your Synapse Analytics solutions. So that is, a very important feature that is now available in Azure Synapse. Right now it's only available with SQL Cosmos DB, but Azure SQL Database and some of these MariaDB, Postgres, SQL databases are going to be added, are going to be supported in this Azure Synapse Link capability. So yeah, so this is a game changer, in my opinion, because now in your cloud native applications that perhaps already in Azure SQL Database, Cosmos, Postgres, MariaDB, and some of these other relational database relational systems, now you can do away with your ETLs, right? You don't need that overhead of developing and maintaining ETLs. You can simply point to those database systems, and now the data is going to be available in Synapse immediately, or almost immediately. Now, this is new technology. They announced that recently, I think back in November, and they started with Azure Cosmos DB, but Azure SQL Database and some of these other Azure relational database platforms will be available in the next couple of months, if not weeks. So keep an eye on that. Really, really a game changer in terms of real-time analytics. All right. So this is the HTAP, or the hybrid transactional analytical processing that Azure Synapse has incorporated into their offering. And again, no need for complex ETL pipelines. You can query your transactional data in real time without putting that ETL process in between. So that's really, really powerful in my opinion. But of course, as we talk about streaming data sets, so other data sets that perhaps don't land in a database, perhaps they are landing in a data lake or in some other landing zone. Typically, those type of streaming data sets, has to be either consumed or batch processed after it has landed, or you have to use some type of like Lambda architecture, where some of that goes into a persistent storage, some of that goes through a streaming pipeline that you're able to query that data as the data flows through that streaming data set. And essentially, what Synapse Analytics allows you to do is to apply SQL-like queries on top of that streaming data set. So for example, if you are sending telemetry data from IoT devices and you want to know what the latest state of a device is, you can have a query that has a where class says where state equals down or state equals unavailable, right? And you can put proactive monitoring on top of those devices, and based on the result of that query, you can see those devices that need your immediate attention based on states or change of states that is coming through. You don't have to wait minutes or hours to see that data. You can see that real time. Right? So that's where the streaming data sets with Azure Synapse Analytics are very important. And there's a very interesting customer success story with Azure Synapse Analytics already and streaming data sets, and that's with a company called TechnoOpin. And what they do is they manufacture these machines that produce snow. And this is for ski resorts primarily. And they are able to monitor in real time, thousands of these snow producing machines with Synapse Analytics, be able to proactively change settings in those machines remotely, or advise their clients with all the knowledge from this telemetry and let them know what is the best way to set up their machines, place their machines, look at weather patterns, and predict, hey, do we need to turn up 3 more machines on, or turn on 3 more machines, or should we throttle down this machine because the ice is not of the quality that ski resort requires. So they're able to monitor all these remotely and be able to advise all their clients in real time and let them know, hey, you may need to change settings on these machines, turn them on, turn them off, in real time, consuming the telemetry that these machines are sending via wireless communications back to Azure Synapse. So really powerful, really interesting use case of real-time ingestion and processing of data with Azure Synapse Analytics. All right, so we're going to now dive a little bit deeper into some specialized capabilities such as machine learning, AI, and also the integration of Synapse Analytics with Power BI. So we're going to take a 5-minute break, and then we're going to dive deeper into these topics. And so let's take a quick break to stretch, to take a bio break, get some coffee, some water, and then we're going to come back and dive a little bit deeper. And then we're going to start our lab portion, which is, I know everybody is waiting, so we're going to get to that in a few minutes. So I'll talk to you in 5 minutes or less. All right, so we are back, and let's continue talking about some of the capabilities of Azure Synapse in with machine learning, and also the integration of Synapse with other platforms such as Power BI, which is really cool. I really like that integration. So with machine learning, in Synapse Analytics allows you to be able to leverage the machine learning models that your data scientists perhaps have created very seamlessly, very easily within, again, the same collaboration environment in Azure Synapse Studio. So now your data engineers will prep the data, make the data available to perhaps in a data warehouse or in a data lake. Now can collaborate very seamlessly with data scientists. They don't have to now use a totally different environment or have to create new silos by duplicating this data in some other format, in some other storage. All of that centrally located within the Azure Synapse data sets that are available both to data engineers, data scientists. And now data engineers can use their preferred, development programming language, SQL, or Spark, whatever they decide to use, and then their data scientists can now use that same environment and use perhaps notebooks, right? Jupyter notebooks, the type of notebooks that can just integrate with those data sets made available by your data engineers, either in a data lake or in a database. And now your data scientists can prep, train those data models with that data, and then your data analysts, business analysts can also leverage those models by calling the models and passing the data that they want those models to predict. So, for example, you want to make a prediction of which customers will buy a particular product. A data analyst, a sales analyst, marketing analyst can use this environment, bring the data using an Excel-like format, and then call the data model to predict which of the customers that they have brought in most likely are going to buy a particular product, for example. All of that, again, into a seamless collaboration space within Azure Synapse and Azure Synapse Studio specifically. So like I mentioned, there's a notebook development environment within Azure Synapse, and it enables your data scientists to develop, prep, train models using their favorite language, that being Python, PySpark, or Python and Spark, Scala, C#, or even Spark SQL, right? In whatever language they preferred to develop, prep, train their models. And it also offers a automatic code completion, so also known as IntelliSense. So those of you who are familiarized with SQL Server Manager Studio or Visual Studio Code, you have that automated completion of your syntax, and it gives you hints of, for example, if you want to read data from a table, it will give you table name, column names that are available within that table. So it really makes the development experience much better. And for those that are not familiarized with the schema, with the table names, column name, IntelliSense just makes it really easy. And also for those of you who are not familiar with Python, for example, and want to start writing some Python using PySpark, it allows you to get that language context and that auto-completion of commands, right? And give you hints of this function perhaps requires 2 or 3 parameters, and it gives you that context. So really great development environment. At the same time, you can also bring in other type of development tools, and you can leverage many industry standard languages and file formats, data types, import new libraries. So it's very flexible, and it allows you to extend what has been built in with other libraries and other modules that you need to incorporate, and essentially use what makes sense to you, what makes sense for the type of workload, and for the goals, right, in your analytic solution. So it's not, you're not pigeonholed. You can easily extend this and have flexibility on the languages, data types, data formats that you want to store this data. Another big added feature into Synapse Analytics is the availability to use what they call automatic ML. And this is a nice feature that they have already available in Azure as a standalone component within their Azure machine learning offering. And AutoML really allows you to do data exploration, data discovery, and be able to understand what is the best predictive model that you can use for your particular use case. So is it, some type of regression model? Is it some type of classification, clustering? And perhaps you don't really understand what model or what type of algorithm you may use. AutoML allows you to run the data through the different models and be able to get the best scoring that's possible, the best accuracy that's available. And then you can decide which model will be the best suited model for that particular workload or use case. Now, that brings an interesting topic that I've had many conversations with our customers, and that is, do you need to be a data scientist to do data science? So in some cases, or in most cases, yes, you need that math background, statistical background, to understand what those data models and the best approach for an algorithm is, what gives you the best results, best scoring, best accuracy, and which models to trust, right, that give you the best of breed. So in most use cases, yes, that is the case. But there's also a conversation of, can a data analyst, can a business analyst do data science without having to go through a formal data science course, data science learning? So in my opinion, I would say yes. And because tools like Synapse Analytics and with Synapse Studio, it really allows those data analysts, knowledge workers, information knowledge workers to be able to use these techniques with the help of technology like AutoML to understand these models better and be able to simply do a quick proof of value, proof of concept, and then bring that into the enterprise. And I think that's where in the maturity model and in that life cycle of any data analytics solution, there is some sort of self-service analytics, self-service data science that needs to happen. and this is part of the democratization of AI, right? Democratization of machine learning and democratization of data science falls into. And I strongly believe that we should empower our business users, our knowledge workers, to make use of these techniques. But it is when you want to bring this to an enterprise level solution, that's where definitely you need to engage your data scientists. That's where you need to have that expertise, validate, and ensure that you're getting reliable results out of your machine learning models, AI algorithms, right? So, but Synapse Studio makes that easy to transition to a self-service, democratized AI and ML in your organization without the inherent risk of misinterpretation of data, data breach, data security issues, right? So all of that within the controls of that you can put forward in your security policies. So really great story about incorporating or democratizing ML in with your operational frontline workers, perhaps, right? And with this, offering in Synapse Studio, using AutoML and using this democratization of ML and AI, it's really a code-free experience, because you can see from the screenshot, you can users can point to a particular data set and immediately enrich that data set with existing data models that either your data scientists have created within your organization, or they can make use of machine learning models, algorithms that Microsoft has made already available. It has already trained with trained data set or already prepared for you that you can just leverage out of the box without major customizations, right? So things like predicting values, looking at forecasting values, stuff like that. Those are really easy use cases that you can just leverage existing algorithms to start exploring and start testing with your own data sets without having the data set leave your controlled environment. And then, as part of that maturity, that growth in AI and ML, then you can engage perhaps the data engineers as well and say, hey, we have this great result with this out-of-the-box ML model or algorithm. How can we extend this and operationalize this within our organization? And then perhaps that's where a lot of data scientists can come in and customize the models, put some additional settings, parameters there that ensure the accuracy and result that you're looking for. But this really democratizes the use of ML in your organization without major configurations, major integrations, and without the risk of data breach, data security issues, right? Only in compliance of your security policies. So so like I mentioned, it is as easy as issuing a SQL-like statement, and using specialized functions called like the predict function, which we're going to see in our lab, and be able to simply reference a model, be able to pass the data that is required for that model, the different features that a model requires, and the model will return back from that query a prediction, right? Essentially a result of that prediction. One great customer story is the AmerisourceBergen story. And they are, if you're not aware, a major pharmaceutical sourcing distribution company that handles a big part of the supply chain of pharmaceuticals in the US. And they needed to empower their business users to make more real-time decisions on the data, get more insights about what's happening in the market and in their supply chain. And Azure Synapse Analytics, with the use of Azure ML integration, was able to provide a very compelling solution to AmerisourceBergen and implement this with their frontline workers, data engineers across their organization, and doing this with the scalability and costs constraints that they had in budgeting, right? So this is really an interesting story. Again, something that I encourage you to look into and read about, because it's a very compelling story about democratizing machine learning. All right, so the next couple of slides is really about the Power BI and Azure Synapse integration. And the reason this is relevant is for many different reasons. One is most likely you already have Power BI implemented in your organization. Maybe you already have a whole operational model, a whole set of policies and procedures and governance around Power BI. So how do you bring that into Azure Synapse? Well, the nice story there is that now Azure Synapse integrates natively with Power BI. As a matter of fact, there is a section in the Azure Synapse Studio dedicated for Power BI, where users can bring workspaces that are already created out there, or they can create workspaces right there from Azure Synapse and be able to develop reports, be able to prep data, transform data, shape their data within the Azure Synapse Studio using the familiarized Power BI development environment, and also publish dashboards and reports within Azure Synapse. This is all powered behind the scenes by the Power BI workspaces, and you can also leverage this through your Power BI web service application or through your own embedded custom application if you're embedding Power BI, for example. But this is where kind of that continuum of the analytics falls into play, right? And this is where the maturity level also falls, and not only in helping you understand what happened, right, with when you're reporting with Power BI. Typically you're reporting on what happened yesterday, the day before, week before, month before, quarter, the last year, etc. And this is more what in the maturity level we call the Hindsight Insights, right? The Hindsight Analytics, being able to describe what happened in the past. But now with Azure Synapse Analytics, now you can evolve and mature in your journey into more of this insight, real-time insight and foresight, right? Predicting what's going to happen, not only what happened, but also why did it happen, understanding the causal factors. And by the way, we have a dedicated workshop called AI in a Day, where we dive deeper into causal factors and a causality service that we offer along with Azure Synapse that helps you understand, sorry, why did it happen? What are the causal factors for certain results? And then continuing in your maturity journey in analytics, then you arrive into the foresight and understand what will happen, but most importantly, how can we make that happen, or how can we make a particular business goal, revenue goal, sales goal happen? And it is important to understand what happened, to understand what are the causal factors, understand why it happened, and how can you affect those results. And this is all part of that maturity level. And of course, as you grow in that maturity, in that journey, things may become a little bit more difficult, a little bit more time, a little bit more data, a little bit more understanding, more specialized skill sets. But at the same time, it increases that value proposition of your data. It really highlights the value of your data. So that's something just to keep in mind in your strategy, understanding where you are in your journey, where you want to be, and understanding that there's some difficulty in arriving at that maturity level. But with tools like Synapse and all the ecosystem that Synapse brings, along with integration with Power BI, you can integrate Power BI and visual type of insights as part of your next, natural step in your analytics journey. And we're gonna see how Power BI integrates in our labs, but it's a really, really seamless experience that I think a lot of organizations will find very useful. So for those of you who have not experienced Power BI, so Power BI is a dashboarding and visualization tool that allows developers as well as business users to ingest, shape, transform the data, and create stunning visualizations and dashboards with literally zero coding. It's really a point and click type of development experience, and does not require specialized SQL programming or other type of programming. And you can do everything from, like I said, ingesting and transforming your data to visualizing reports and dashboards, and make this available really, really easily in your enterprise. And with Synapse and Power BI, it makes this integration seamless to the use of the Azure Data Lake storage, the use of relational data sources, but also through the specialized data sets being available through the Common Data Model and Common Data Service in Power BI. And in Power BI, you have the ability to scale those visualizations, right? So one situation might be that in Azure, in Power BI, you might be importing a ton of data. And at some point, as your data grows and then you import more data into a Power BI model, you take a big performance hit. So you have an option with Power BI and Synapse to connect to those Azure Synapse datasets and storage in what's called direct query mode. And direct query mode, as the name implies, is essentially sending the queries back to Synapse and then returning the results back to the Power BI visualization, so that you can really churn and scale your visualizations and your visual insights, and putting the performance, putting the processing in Azure Synapse rather than on Power BI. It's a really interesting use case and implementation of Power BI. And from the customers that have already implemented Power BI along with Synapse, Microsoft has made these great statistics available and some of the ROI achieved, bringing the experience over 250 to 270% ROI, 26% lower total cost of ownership, and 27% faster time to insights, and overall, increased satisfaction across the organization, because now it's a seamless experience between visualizing your data, reporting and dashboard, and all the data preparation, data engineering that comes with any Power BI implementation. And a key example is the Procter & Gamble story, in which they integrated Azure Synapse Analytics with Power BI, and were really able to scale their solution across many across a dispersed geographical user base, and be able to really gain a lot of satisfaction from their account managers, brand managers, and all those supply chain planners and analysts, and really bring a lot of value quickly into the organization with minor friction. So I think this is another story that if you're already implemented or planning to implement Power BI and looking at implementing perhaps a analytic solution such as Synapse to be able to unify all this experience, Procter & Gamble is a great story that I encourage you to read and see how the strategy that was put in place to make that happen. So we're gonna jump into the labs in a couple of minutes. I just wanna leave you with an understanding of where the Azure Synapse availability is. Right now is pretty much in all the major zones, but they are rolling Azure Synapse in many other regions as we speak. Also, that Microsoft is not alone in their in this offering. They are partnering with many other third-party vendors and other platforms out there. So if you already have implemented some type of analytic solution with them, you can integrate this with Azure Synapse. It is not an exclusive service for those for those Microsoft services. It also integrates seamlessly with a lot of these other partners. And there's some specialized connectors that are already available for them that you can leverage Synapse with. And then, in addition to that, Microsoft has made available several accelerators that you can take advantage. So if you are looking for data sets, I know there was a question in the Q&A section about making some of these data sets available. So, the data sets that are available in the labs are actually available through the Knowledge Center that Microsoft has made available. So data sets like the COVID-19, statistics, some of the weather, NOAA weather, historical data, and some other interesting data sets that have been kind of made available for many years, like the New York City taxi database, some of the FAA data sets. So a lot of these publicly shared data sets are already made available there in some type of data lake or relational database that you can simply deploy into your Synapse workspace or Synapse Studio workspace and start playing with these data sets, right? They also have a lot of accelerators around, machine learning notebooks and machine learning models that you can easily take advantage of, like right away, if you want to start exploring and experimenting with this. And then in addition to some of those accelerators, we have also, or Microsoft, sorry, has some offerings that you might want to take advantage of, especially if you're looking at migrating from different platforms, or even integrating from those platforms, such as SAP, Click or ClickView, Tableau, Informatica, and some other of these platforms. And there's a proof of values that you can take advantage of that Microsoft will fund, and different flavors of that, like a free deep dive sessions, which we actually deliver to a lot of our customers, half-day, solutioning, architecture workshops, and visioning workshops. They also made available software subscription and Azure credits, and just availability of subject matter experts to help you come up with a plan or a strategy, a budget to migrate off of these platforms into Azure Synapse, or to take a hybrid approach, perhaps initially, and have a integration between Synapse and your existing platforms. So there's accelerators and offers for Click, SAP, Informatica, and many others that Microsoft is making available, as well as just general offers and incentives that Microsoft is making available. If you're planning to migrate some of those workloads into Azure Synapse, there's actually a very time limited offer that you get 76% discounts if you migrate to Synapse Analytics before May 31st, 2021. So that's something that I would highly recommend you to look into, because these are really, really deep discounts to allow you to, eliminate that barrier, that budget barrier, right? And uncertainty of how much it will cost. You have that deep discount offer right now that's available until May 2021. So take advantage of that, and you can learn more about it in that Synapse migration offer link that we can make available in the Q&A as well. All right, so with that said, we're gonna break for our lab. And we're gonna take a 10-minute break. Originally it was gonna be 15 minutes, but I wanna take just a quick break, get some lunch, some coffee, stretch, and then we're gonna come back and start with our hands-on lab. You should have received an email with instructions on how to register and activate your lab environment. Everybody gets their own personalized lab environment with all the data sets and all the environment already configured. So please look at that email while we're on the break. But I'm also going to walk you through those instructions when we come back. So let's break for 10 minutes or less, and then we're going to come back to do the labs. If there's any questions or issues, please let us know, and I will try to answer those as we come back from our break. So I'll see you in 10 minutes or less. All right. Hopefully everybody's back. And we're going to get going with our labs. So, all right. So in terms of our labs, you should have either received an email, or if you look at the Q&A chat, a link to register for your lab environment to be created and set up. So can everybody like the Madison, the moderator's chat message about activating your lab environment so that I know everybody's good to go? Or if you have any issues, challenges, let me know. You can paste it on the Q&A section. So if you look at the top right, you should see a little question mark, and you should see the messages. One of the messages is where the link is to the lab environment registration or activation. And let me know if you have any issues. If not, I will start with our lab. So let's see. Whoops. Let me share my screen where I'm going to be working on the lab. All right. So let me share again. All right. So you should be seeing my Azure Synapse Analytics lab environment. And this is the environment or the landing page that you will get once you log in with the credentials provided. Now, you have an option down here on the bottom right. Let's see if you can see that. It's right here that says split window. And I find this very useful. If you have two screens, what I do is I put the Synapse Lab on one side, and and then I work on my environment on this side. In the instructions, you will see that there's a section here to turn on your machine, your virtual machine. You don't need this virtual machine unless you have some restrictions in your laptop or desktop that you're using. And I'll be able to log into the Azure portal using your laptop or desktop. So you can use that virtual machine to log in and launch the Azure portal from there, and then also be able to launch the Azure Synapse Analytics, Azure Synapse Studio from a web browser within that virtual machine. So you don't need this, but if you need it, it's there. You need to turn it on. And then once you turn it on, you'll be able to connect to it and remote desktop into that virtual machine. In my case, what I'll do is I will navigate to my portal.azure environment. As a matter of fact, let me go back because by doing that, it closed my lab web page. So I'm just going to open a new tab and connect to my portal Azure environment. And I'm going to change to my Cloud Lab user that was provided. And when you log into the portal, Azure portal, you should see these resources created. They will have different name, but you should see the same type of services. So before I get started, let me see if there's any questions or issues. Okay, I don't see any. Okay, if there's no issues, then I will get going. So once you land in your Azure portal, you will see that there's a resource group called Synapse AIAD, Analytics in a Day. And in this research group, you have several services. You have a blob storage, a data lake account, a Spark pool, a SQL pool, a Databricks cluster, or Databricks service, and you also have a Azure Synapse workspace. So we're going to launch that Azure Synapse workspace, and if you click on it, you will see the service blade for the Azure Synapse Analytics workspace. You can then copy or click on that URL, or you can also click on this open section to open that Synapse Studio development environment. So now you can X out of this message if you're getting this cookies message, or accept it. So now that we've launched our Synapse Analytics workspace, we should be able to see on the left-hand side the different sections, the different services that are part of the Azure Synapse Analytics Studio. So home brings you to the kind of the landing page where you can see, recent resources, some learning options here, or some accelerators to do some activities, some tasks. You also see the data section, where if you expand this, you should see a list of databases. And we're going to be using the SQL Pool 01 and the SQL On Demand 01 databases in a little bit. You can also see under Develop, where you should see all the SQL scripts that have been preloaded for this this workshop environment, along with certain notebooks, some data flows, and a Power BI workspace, which should be blank at the moment, nothing in there. Then you have a section for Integrate, and this is where you will see your data pipelines. You should also see a Monitor section, which you may or may not see nothing there. I played with this environment last Friday and yesterday. So I see some executions here that I already ran yesterday, but you might see this empty. And Monitor is where you monitor jobs and pipelines that you have run, and then Manage if you want to do some configuration with your pools and some other services. Now, if you go to Manage, you would see that that SQL Pool 01 environment is paused. So let's go ahead and click on this play button or resume button right here. And that will turn on that SQL Pool on, or resume it in this case. And I want to do that because it takes a little while for it to come up. And so while we go through the lab, it should be on when we need it. All right. So with that said, let's walk through our analytics lab. And the data that we're going to be working today is the Worldwide Importers database. And this is data that a database that Microsoft makes available. You can download and install this SQL database if you want to. If you just Google search Bing or Google WWI SQL sample database, you should see a page that talks about the sample databases, and you see the link there for GitHub, where you can download the Worldwide Importers database and different datasets made available, including the Worldwide Importers data warehouse database. So this is just a sample database from a fictitious company that Microsoft makes available that we're going to be working on today. And we're going to be working today with the exported or extracted data out of that database into a data lake. So we're going to be consuming like the fact sales data and customer data from extracts made out of that database, SQL database, into the data lake environment that we have. Also, please be aware that there's an environment detail. So if you see on the top here, you see lab guide, which is what I'm reading right now. Then you have a tab for environment details. And in that environment detail, you have your credentials, the username and password. So you can go to that environment detail, copy the username. That's the username that you're going to use to log into the portal. and the corresponding password. And then you would see your unique ID, which is going to be used to replace some values in our lab environment. And I'll walk you through when we need those values. And again, you can turn on that VM and make it available if you need to remote into that desktop environment. All right, so and today what we're gonna do is we're gonna do several labs. We're gonna do all of them because of time, but we're gonna walk through the exercise 1, 2, 3, and 4. We probably not get time to get to 5, and also there's a small issue with the lab for exercise 5 that I want to talk about if we have time. But for the most part, we're going to get through most of them, if not all. So with that said, is there any issues that we need to address at the moment? Anybody having issues? No, I don't see anything in the Q&A, so I assume everybody's good to go. So the first thing we're going to do is we're going to explore the data lake with Synapse SQL on demand and Spark. So we're going to do the same lab with 2 different engines, the SQL on demand using a SQL pool and the Azure Synapse Spark engine as well. So everybody, let's log into our portal if you haven't done so. And if you haven't done so, also make sure that you go to under manage and turn on that dedicated pool. I already did it and it's online now. And the first thing we're going to do from our lab is we are going to analyze some data. And we're going to click on the data tab here on the left. You can expand that or collapse it so you can a bit more real estate. And under our data section, we're going to go under our SQL pool 1. Sorry, we're not going to go to the database section right now. We're going to go to the data lake section. And in order to go to the data lake storage, we go to our linked tab right here at the top. When you click on that tab, you'll see that now we have our linked storage and other data sets available in this environment. The first thing we're going to do is we're going to expand the Azure Data Lake Gen 2 environment. We can expand this a little bit more if you want. And we can then expand the AAS workspace. This number should be different for you. Should be your unique ID. And in this data lake storage, we have a container or folder called WWI, which means Worldwide Importers. Inside that folder, we have 2 folders. One is the fact sale CSV, and the other one is fact sale Parquet. And what that means is that we have 2 folders with 2 exact same information. One is in CSV format, the other one is in Parquet format. So we're going to work today with the Parquet files. So we're going to double click on that folder. And it will show us the subfolders within that main folder. We're going to navigate to our 2012 folder, key 1. And we're going to go into this folder, which uses sort of like a partition by day, the way they're partitioning the files. Essentially, for each day, they export all the data from that day into individual folders. That's denoted by this partition key, right, in the invoice date key. We double click on that first partition folder, and we will see a file. And as you can see, this is a .parquet file. And for those of you who are not familiar with Parquet, Parquet is a specialized data file format that contains both the data itself and the metadata. And essentially, think of it as a self-contained table, right? That has the column headers, the column data types encoded along with the data itself. So it's a very fast file format to be able to read data, get the metadata out of the data, and not only that, but be able to be selective and only select certain rows out of the file without having to read the entire file. So it's a very, very optimized file format that I recommend to almost every customer that requires fast, reliable data file formats. And then you see also Snappy, which is just a compression method called a Snappy compression, essentially like a zipping compression of Parquet files. So not only it is in optimized file format, it's also compressed, which makes it smaller and less data to shuffle around. So we're going to arrive to this initial file, and then the first thing we're going to do is we're actually going to select the data in a SQL with a SQL query from that Parquet file. And the way we do that is we right-click on the file name, we select new SQL script, and select top 1,000 rows. Now, in this case, we're going to use the built-in pool, which is like the default pool SQL pool resource. And you can see that when we did right-click and select top 1,000, it automatically inserted the SQL syntax for us to read from that file. Again, it's a Parquet file. You can also close this section if you want more real estate by clicking on this icon right there, and that makes it go away. You can also collapse here and collapse there, so you can get more real estate. So you can see the query that it generated, and it's essentially an open row set query using a bulk read of a file that is formatted as Parquet, and selecting the top 1,000 from there. So we're gonna click on Run, which is this button up here, and we're gonna execute that query. Now it's gonna take a little while to read and display the results. Well, actually, really fast, less than 5 seconds. Or microseconds, I guess, because there's nothing in cache. The resources had just started, so there's nothing running there, and we're reading this data for the first time. But you can see that we can really easily read from file formats in data that's not stored in relational store, even in non-relational stores like Data Lake, Parquet, CSV files. Really quickly. And here we can just, change this to, instead of top 100, we're saying top 1,000. Let's run that again. And now we should see, top 1,000 records. And you can see that now, even with 1,000 records, the performance is very quick, right? It's sub-second performance. So yeah, that shows you how to very quickly select data from a file-based storage. We can also change this to, instead of selecting the top rows, we can see how many rows of data are we dealing with here. So we're going to change that select statement to a count star from that same file, and we're going to run this really quick. So why is this not count star? It's unfortunately it's case sensitive, so it has to be uppercase. So in this file, we're dealing with 32,000 rows. So yeah, I mean, you expect to query a file with 32,000 rows relatively easy. But instead of selecting data from a particular file, how do you select data from multiple files? There's a couple of ways. You can essentially list all the files you want to select data from, or even better, you can point to a particular folder and say, I want all the data contained not in this particular date folder, but I want all the data in a particular quarter, for instance, right? So the format will be, I want all data in the subfolder of Q1 and all files under those subfolders, right? So it's star /*. And let's run that again. And what it's going to do essentially is going to read all those Parquet files that are contained under the Q1 folder, read each of those Parquet files, and essentially do a count for all files contained under the 2012 Q1 partition. And we can see that we have 2,981,716 records in those files. Very easily, as you can see, if we go back to our data, let's WWI, and essentially what we did is, instead of selecting from a particular partition folder, we actually selected all files under the Q1 and count records contained in each of the files under each of these folders, all within a very similar programming language, which we all know, most of us know, which is SQL, correct? So that was very, very easy. So now what we're gonna do is we can close this script. You can discard changes, and we can close this. And now we can go to our develop section. So if you expand here, you see that this icon corresponds to the develop. And we're gonna open our exercise 1 script. So in this exercise 1 script, what we're doing is now we are instead reading from that the CSV version of our data. So before we read from the parquet, and as you notice from our parquet, we not only got the data, but we also got the column names and the data type that correspond to those rows. But now we're gonna learn how to read from a CSV file, which doesn't have any metadata in it. And the way we read this is very similar. We just point to that folder. We point to the folders and subfolders we want to read from. In this case, the same Q1 structure. In this case, it's not parquet. It's going to be CSV. But also we need to provide what is that field delimiter that or a terminator for each column in our rows. Are there any quoted fields, and also where do we start reading data rows as opposed to the column headers? So that means that this file may have column headers, may have a space, may have like a title in the first row, and we can skip those rows and actually start reading the data from where they start. In this case, they start in row 2. But in addition to that, we are providing the schema that we want that data to be read as. In this case, the column names and the data types for them. So now we're going to execute this, and we should see open row set. Oh, okay, this is built in and under SQL on demand. I forgot this step. So you have to change this to built-in and SQL on demand 01 to work, because this is pulling from a different pool. So let's run that. So the reason we had to specify what resource we need to connect in database is because that's how Synapse knows how to interpret and parse the commands that you're providing, and also it also knows how to point to the right data given the resources. Some resources may have access to some of those data sets as well. So from that query, using the CSV format of the files, we can see that we obtained the same number of records, right, from that count that we did. 2,991,716 records. The difference is that when reading from CSV, you have to specify additional information, such as how to read the data, how is the data delimited, where does the data row start, and most importantly, the schema of the data. And here, if we do a select top 100 star, you will see that we get the what's the message? Interesting. So there, so this is an issue with the schema that we provided, right? So it's telling us that some fields or some rows in some of these files contain errors because data is being truncated. And I forgot the option, but there's a option to omit error messages due to truncation because perhaps we specified a small string size here, which I think is the main cause of the issue. No, it's other column, so never mind. But essentially, this is the additional information that we need to provide when reading file formats that don't have that metadata stored with them, such as Parquet, right? So that's a very simple exercise. Now, the next thing we're going to do is we are going to now explore this same data, not with a SQL syntax or using a SQL pool, but now actually using Spark. And the way we do this is very simple. We go to Data, and we click on our WWI folder, and we navigate. If you haven't navigated to already, we're going to navigate to our cell Parquet 2012 Q1 back to our invoice date key folder. And here we're going to right click, but instead of choosing new SQL script, select top 1000, we're actually going to create a new notebook. And we're going to create a data frame out of the rows contained in that file. So we're going to create new note. I'm going to click on new notebook, load to data frame. And as you can see, Synapse Studio automatically creates the, in this case, the PySpark syntax to read from that particular file that is located in that section. And it's specifying that we're going to import that file, which has a format of Parquet, into a data frame called df. df equals means this is a data frame, and we are assigning that data frame the rows that Spark is reading from this file. Then it's also saying display the first 10 rows that you read, right? So we're going to run, we can have two options here. We can click on this ellipsis section here, and we can click and say run cell. We can also select run all, but as you will see, as you add more cells, you don't want all cells to run again and again and again. You want to be more selective and say just run this cell, or you can use the keyboard shortcut of Control Enter, and it will run just that cell. So that's what I'm going to do right now. I'm just going to click, press Control, hold Control on, and press Enter. And what's going to do is it's going to start a Spark session. So behind the scenes, this is a Spark pool. So a set of nodes that has a Spark driver, one or more worker nodes. And it's using a kernel. In this case, it's using the PySpark or Python kernel running on Spark. So again, this is something that you can, in the environment was already set up for us. But if you're interested, there's a guidance on how all this was set up. And you can essentially replicate this environment in your own testing environment for learning purposes. And I'll show you that in a minute or two. Unfortunately, this environment that you're accessing will go away by the end of the day or before the end of the day. So we only have like 2-3 hours available on this environment. But the data set that's available, like I said, is either made available through that GitHub sample database, worldwide importers database, or through the accelerators that I'll show you in a minute, in a few minutes, how to get to those accelerators from Synapse. So what's happening right now is the reason why it's taking a little bit long is because it needs to create a session. It's passing our credentials. So these are my credentials right now, the ODL_user. It's handling the authentication into Spark, and it's actually starting up the nodes that are defined into that cluster, into that Spark cluster. A lot of these services like Spark and SQL pools are dedicated pools, meaning they're ready, they're there and they're running waiting for you to execute some type of job or script. Others are in a dormant state, essentially are paused. And that's sometimes the first time you interact with these clusters. That's why it takes some time, because it's starting up, waking up those nodes. Then it's distributing the load across those nodes, and it's actually running the job that you specify, or the script that you specified. Now we see that the Spark cluster is on, it's awakened, and we can see that we have 2 executors, and I guess it's 4 cores each, so a total of 8 cores. And if you don't understand the Spark architecture, I encourage you to read about it, but essentially there's a driver node, a node that manages and sends the work to the worker nodes. Worker nodes process the data and then send it back. So having the right number of worker nodes, task nodes, and some other special nodes is key. It's essential to be able to scale your solution. So we see that in our session, in our job, we said, let's read data from this per K file and display the first 10 rows. And that's exactly what it's doing, right? It's displaying the first 10 rows in a table for us. Now, this takes a little bit longer, but if I rerun this, I can rerun this cell again, it should take a lot less, right? Boom, almost instantaneous, right? And if I run it one more time, it will be even quicker. And the reason is because now the data now resides in the Spark memory, in the Spark cache, and now it's able to retrieve this data quicker for us in a from memory, right? We can also see that it initiated 2 jobs, actually several jobs, and what each of the job duration and the result, right, of each of those jobs. So we can see really good information about that. Now, by default, it will show you the data or the results of those 10 rows in a table, but we only have 10 rows, so let's expand that to perhaps 100 rows. So let's change that to 100, and we should get back 100 rows. And also, it returns it almost immediately. But we can take advantage of some of the built-in visualization options. So you can see that we have the option here to see the data as a table or see the data as a chart. So I'm going to click chart, and it's going to try to visualize the data, take a best guess of where to put the axis, columns, value columns. So it doesn't do a good job in this case. So what we're going to do is we're going to click in this view options icon right here on the top, and we click on that, and we can see where it has placed our columns. So on the key, what we're going to do is we're going to change this to be, instead of cell key, to be the customer key. And then in our values, it will be, instead of the cell key, it will be the city key. And what we wanted to do is not to sum up or aggregate on the actual values of the city key. We actually wanted to count, which is what it's doing right now. But you can choose if it was actually a measure that you want to sum, average, get the min-max. You can change the aggregation type here. But in this case, we're just going to do a count of city keys by customer. And then we're going to hit the apply button below here. And now we should be able to see the count of customers by the cost of cities by our different customers, right? So really quick way to get good insights, to analyze the data, all within the same environment. All right. We can hide all this if we can click this little button right here, and that button allows us to collapse the results. So if you click there, it should collapse that. And now what we're going to do is we are going to add an additional cell. So this square or this section that we see here, let me highlight that for you. this. Yeah, so all this section, as you can see, is a cell, right? All of that's square is what's considered a cell in a notebook. Now, if you hover over the border right below that cell, you can add a new cell by clicking on the Add Code. Okay. So now we have one cell 1, and now we have cell 2. So in that cell, we're gonna copy this script that you have in your lab. So you should be able to see that. And we're just gonna highlight, and it doesn't have a right-click copy. And then now in the notebook, you don't have a right-click paste, unfortunately. So just do Control V. So Control and V as in Victor, and that should allow you to paste that code. So now that we have pasted that code, all we're gonna do is let's run that cell. And we're gonna see now the same result, or we should see the same result, right? Of the 100 rows coming from a Parquet file, and the same results coming now from a CSV file. So the exact same number of files, just showing the first 100 rows. So we're gonna wait for that to run and execute. And that's taking, again, a little while because it is the first time it is reading those files from storage. And but once we get those files in memory, or the rows containing those files in memory, then it will be able to return that data much faster. And we'll see the same result when we change that to perhaps 1,000 rows rather than 100. So the first time, it always takes a little while. And just remember that, you know, we're dealing with millions of records right now, 2.9 million, which really is nothing. It's, you know, a blip in for Synapse Analytics. But typically in this type of platforms are used where you have, you know, not gigabytes of data, but also petabytes of data, you know, hundreds of millions, if not billions of rows. So it is optimized to read a vast number of records in the shortest amount of time. So if you try to compare the time it takes to run a query against a couple hundred or maybe million rows versus, you know, a relational database, it might do it quicker because that relational database already has the data parsed in a relational table. It already has an execution plan. It already has maybe some of that data in its buffer, right, in its cache. Versus here, where we're starting from a cold cache, cold buffer, and it is reading through all those files as quickly as it can and distributing that load among many nodes. So in order to speed up that process, you need to have the right partitioning. You need to have the right number of worker nodes or executor nodes. So there's a balance on how to do that. Sometimes it's kind of an art, but it's really kind of, you know, well-known data practices where, you know, if you are going to be reading most of the time data that is only in the last 2 years, maybe partition that data by date, as we saw already in this example, so that we can see the data. Let's see, we got an error. I think I had this error before, and the reason, let's run it again, and I just run it again and it worked. Oh, I know, sorry. Yes, I forgot. My bad. So I want to cancel this. So what happens is in this exercise, I forgot to change this value, right? And as I said, this value comes from a unique ID that's in the Cloud Labs environment. You could also see it here in that previous example if you still have it. If not, you will have to go to the environment details section here to see what your unique ID is, or you can grab it from here, which is this data lake name that we're using. Unfortunately, this doesn't have a copy, so we're just gonna Control C, and then we're gonna Control V. And now I should run it. Should be able to run it successfully. All right, so let's wait for that data to be read. So important, read instructions, that's for me. And second, you need to grab your particular data lake name from your environment. So don't use this same data lake name, because this is only for my environment. You should have your own environment. There any questions or comments around that? No? Okay. So let's wait for that data to be read. So yeah, so it's parsing through all those files that are in CSV format, and because it is not a optimized file format, it has to do a lot of parsing with the rows, getting the separator, in this case a pipe delimited file, and reading from each row, reading the first row as the header, that has the field names and the data types. So it's going to take a little while. All right, let's see. All right, so while that's running, the key takeaway here is that you can choose the file format, the layout of your storage. If you want it to be relational, you can read from a database, which we're gonna do in a little bit, or you can choose to just have files sitting in a blob storage or in a data lake. You can choose the file format, CSV, Parquet, Avro, or JSON, pretty much any type of file format that you choose or prefer to. So we're gonna let that run. Actually, it's running already. That's cool. And we should see the results in a minute or two. We also should track the execution. You should see that it's already succeeded, and we get back the same results there, right? Again, if I run this again, the results should return almost instantaneously now, because it already has all of those files in its buffer, and now the data returns much quicker, right? So that is all for exercise 1. So we're going to close this, and we're going to discard changes, and we're going to go back to our lab instructions. So the next thing is building a data warehouse with Azure Synapse pipelines. I'm not going to go through the entire exercise. I'm going to show you a part of it, and then I'm just going to show you how it looks, because we already have this lab done for us, and you can just explore how to work with that data, with those pipelines. So the next thing would be, we are going to go to our develop section, and we're going to create a new notebook from scratch. In order to do that, you see that there's a little plus sign here. If you click on that plus sign, it prompts you to select what do you want to create: a SQL script, a notebook, data flow, Apache Spark, a Power BI report, etc. Right? Or to import something that you already built, like a notebook, right, or a script. In this case, we're going to select a notebook. Now, we're going to select also from our resources, we're going to select, or make sure that we have selected our Spark Pool 01. And the language that we're going to use is not PySpark, but Scala. Now, notice the options that you have. You can work with Python on Spark. You can work with native Scala on Spark. You can actually work with .NET C# on Spark, or you can choose to work with Spark SQL. So you have flexibility on the languages, the environments that you want to work with. In this case, we're going to work with Spark Scala, which is the native language of Spark, essentially. Then next, we're going to click on Add Code. so we can have a cell that we can create our notebook analysis. For these purposes, we're going to copy this script that's already created for us. So I'm going to copy that, and I'm going to paste that in here. Now notice that we need to provide that data lake name. So the easiest way to do that, just if you want to take a shortcut, is you can just go to your data, and then grab like a file, new notebook, go to data frame, and just grab that name from here if you want to. Or you can go to your environment details and copy it from there. In this case, I'm just going to copy it from here. And close that. Close that. And now we're back here to our notebook that we just created. And I'm simply going to replace that data lake name in here. So important, make sure that you're attached to this Spark Pool 01 cluster, and that you have selected the Spark Scala language to run it. Now in here, you can see this is what's called the magic keyword, or the magic word, to let the interpreter or the IDE, in this case, Synapse Studio, know that we're working with Spark Scala. We're going to import a library to initiate our session. It's a library or method to initiate a Spark session. And then we're going to assign to a variable called ADLS path, the path of our ADLS lake. Okay, so we're going to run that either by clicking Run Cell or pressing Control Enter. And what that does is it's initiating our Spark session, initiates the kernel if you haven't used that, which is in this case the Scala kernel, and it is importing this library and defining this variable ADLS path. And we're going to wait for that to show, to display or complete. All right, so now it has imported that library or session, and it has assigned to an ADLS path variable this value. Now we're going to add a new cell, and we are going to copy from the lab the next script. Copy that, and we're going to paste it there. And the next thing it's going to do is it's going to assign to a sales variable the content from files of CSV format that are in our ADLS path. And the best way to interpret this is if you press enter after the dot, you can break this down in a little bit more readable form. All right. So essentially, and actually, let's cut this out of here and add it to the next cell. So essentially, in this cell, what we're going to do is we're going to define a data frame or a file, a variable or RDD frame called sales. We're going to use a Spark read method, and this is going to read from a CSV formatted file or formatted source. We are specifying that it has a header, because we're saying header true. This file has a header. We're also going to specify that we don't know the schema, so we're going to have Spark interpret or infer what is the schema contained in those files. And it does that by sampling the data. And if it has numeric files, then it's going to be a numeric column. If it has dates, it's going to be a date string column. We're also saying that this is a file, a CSV file that is pipe delimited. So we're going to set that as the separator. And then we're going to load it from this path. In this case, it's going to be the fact sale CSV 2012 folder, Q4 folder. So we're gonna run that. And now our sales variable will contain the rows from these files that is reading. So at this point, we're just saying load the data from these files into a sales variable, or more specifically into a RDD or data frame, if you want to call it like that. Again, all of this is happening in memory. So think of it as a temp table that's in memory. Now that we have loaded that data into that sales variable, we're going to say from the sales variable, show 5 records or show rows. So we're going to do that first. I'm going to take this out, put it into a new cell. So we're going to show the first 5 rows or records from that in-memory table. So we're going to run that. And we can see a quick preview of the data contained in the data frame that we loaded, or in that temporary in-memory table that we loaded. And then the next thing we're going to do is we're going to ask to show us what is the schema that it inferred from that first cell here, cell 2 that we asked, infer schema for us. So let's see what schema did it infer for us. So we're going to execute that. And we can see that it inferred the schema based on the first the first row of data. And it inferred that a lot of these were integers. There's a lot of null values, perhaps, because null equals true. So maybe there's some empty records there. Some of them are strings. Some of them are double or numeric. And I don't see, and I see a date here. So it was able to sample the data and infer the schema by using that infer schema option specified in there. All right. So the next step is now that we have done that, let's read that data, but also output the data into a table. So we're going to add code, and we're going to copy this script from here. We're going to paste it. And you can also, again, you can collapse these results if you want more. If you don't want to scroll too much, you can hide all this. And there's also an option there to hide all if you want to. Okay. So we pasted the script from the next section. And what it's doing here is it's importing additional libraries that we're going to use as part of our next step. And what we're going to do is, in this next step, is we're going to write the first 10,000 records from that sales in-memory table or data frame into a table called SQL_1.wdi_staging.sale. So just like a relational database, like SQL Server, you have database name, schema name, table name, right? And if you look at our data section here on the left, and you click on the workspace, you will see that this is referring to the SQL_1 database. If you expand that, you will see that there are several schemas. Let's refresh this. For some reason, it's not coming up. That's interesting. Let's see what's happening here. Ah, it's paused. Interesting. Okay, let me resume that. Hopefully it doesn't take too long. So if you had that issue, check your SQL pool, make sure in there manage SQL pool to make sure that it is on. For some reason, it was paused. So, so if it's not on, you will not be able to see your data assets because the metadata related to those data assets, in this case, your tables and databases, are provided by that pool, SQL pool. So let's monitor that. It's resuming. And we should see those tables available once this pool is available. Anybody else having that issue? I'm not sure if this is a something that the managers of these environments turn off for some reason. I don't see any comments around that, I guess. So let's wait for that to resume. There we go. Now it's online. So now if we go back to our databases section, I'm going to refresh this. And now we should be able to refresh our tables. And here you can see that we have a schema called several schemas, WWI, WWI_ML, WWI perf. In this case, we're going to create essentially a new schema at the same time that we're going to create a new table called WWI staging.sale. And essentially, we're just going to read the data from the sales data frame or in-memory table that we specified here. And we're going to write that data into a new table called table name, which is this table name here. So let's execute that and wait for the results. Now we may get an error, maybe not, because the pool was stopped or paused, so it may not be. My session might have been disconnected. Probably not. I think we're in the resume the session, I guess. Oh no, we're in the Spark pool. Sorry, this is the Spark pool. So it was the SQL pool that was paused. So knowing where your resources in your assets and knowing which assets are served by different pool of resources is very important. In this case, our database or metadata assets are served by the SQL pool. We are now connected to the Spark pool, which is for the running of notebooks and Scala and all that. So now it succeeded, and what we can do is we can click here on this ellipsis next to the table name or even the database name, and we can click refresh. And if you once you refresh and you expand the table section, you should see a new table called WWI staging.sale, which is exactly what we specified here. Now that we have created that table, you can see we can actually select data from that table immediately. All right. So yeah, so that is essentially the main focus of this lab. The next set of steps, as you can see in the lab environment, is walking you through the data integration capabilities. We're not going to go into the detail of creating those, but if you go to the integrate section, you should see under exercise 2, the enriched data pipeline. You can see these are pipelines. You can create new pipelines. And in this pipeline, essentially what they're doing is we have a copy data activity. And what this copy data activity is doing is selecting data from a Azure Data Lake store. In this case, customers that are loaded into a data set defined as dim customer ADLS. And essentially it's pulling our customers, and it will be copying that data into a another staging table called dim customer ASA. The next activity is a data flow activity. And for those of you familiarized with SSIS, it's similar to SSIS where you have a control flow, data flow. And inside that data flow, if you double click on it, it actually opens what that data flow is doing behind the scenes. And what it's doing is it's pulling data from a source called postal codes, which is in an ADLS. Then it is filtering those records for zip codes in greater or equal to 9,000 and less than or equal to 98,000. It's also pulling data from a dim customer source and then joining these two sources. You can see it by this reference here. So this is a join to that filtered source. And then it is selecting just a specific set of columns and then writing those to a enriched customer data into the data lake. And it's also creating a table or populating a table called staging enriched customer ASA. So what we're going to do is we want this to run in sequence. And this is where this is actually essentially Data Factory behind the scenes, right? So this is Data Factory within Synapse. And if you're already familiar with Data Factory, you can create or orchestrate the sequencing of your data activities by connecting an activity with another and creating essentially success constraints or precedence constraints. So essentially, this is saying that this data flow is going to execute until our copy data activity executes. And we can do this, now we can schedule this, or we can run this on demand. We can click on debug, or we can create a trigger and say trigger now. It should be executing our data. We can also, if you have a trigger defined, because trigger now, it's a little misnomer, essentially trigger an already created trigger. So we're just going to click debug, and actually, it's actually running it. I thought it didn't want through. It's running. So I'm mistaken. So sometimes the trigger now, or beforehand, actually expected a trigger to be created. So now that it's running, you could see what the outcome of that trigger is by looking at the monitor section. So if we now go to the monitor section, we can see what is actually running at the moment. And it should come up sometime now. Yeah, click on that. Also, there's a shortcut there. There we go. And now it is going to show us the progress. So it is showing that it's going to run a particular activity first, then it's going to run the second activity. We can see what's happening. If we click on the, let me show you that. If you click on this icon, if you hover over this line and you click on that eyeglasses icon, you can actually see what's happening real time. This might take a little while because it's turning on a cluster and preparing all this. So I'm not going to wait for it to run. But once this finalizes its execution, or even while it's running, you will see some statistics populated here. And then you can see what the execution results were after the execution. So let me go back to monitor. And let me show you one that already runs. So I'm going to click on this pipeline run that I did. As you can see, in this particular case, it's exceeded. And we can actually see a Gantt chart of how long it took for each activity to complete, how long it took. And that is important because we can see through multiple executions if it's taking longer and longer. So we might need to do some optimizations, right? Or we can know at what step it failed and we can resume from there, right? We can also see from our output some of the parameters in the actual JSON script that was used to execute this pipeline. And if you go back to those eyeglasses, like I mentioned, you can see the overall picture of how long it took, each of the different steps in that data flow or mapping data flow. And then we can actually click on a particular activity, in this case, the join activity, and we can see, the statistics related to that particular activity, right? So we can be very, we can explore the things that are happening and how we can monitor and understand how those pipelines are executing. All right, so that concludes the exercise 2. I think we're running a little bit out of time, but I can stay for another 30 minutes and finalize the last lab that we're gonna wanted to cover today, which is the Power BI integration. It's a really cool lab that shows you that seamless integration between Synapse Analytics and other services, like we already showed you, like Data Factory, using those the integrate section, Spark in SQL, pools that you can use, SQL and Python and SCADA. And now we're going to show you how to integrate with Power BI. So if you don't have Power BI Desktop installed on your laptop or desktop, you might want to hop on the VM. That VM already has Power BI installed, or you can actually install Power BI Desktop now. It just takes like 2 minutes install, and very simple process to install it if you have the permissions rights to install it. So in this case, what we're gonna do is we're gonna create a Power BI dataset of an existing database that we have, in this case, the SQL Pool 01 database. So in order to do that, let me go back to develop. And here in Power BI Desktop, I'm going to click on the plus sign, so up here. And I'm going to choose a Power BI report. Whoop, sorry about that. Power BI report. Or actually, in instructions, it's actually telling us to go to a Power BI dataset and adding a new Power BI dataset from here. So you have 2 options. You can do it as a report. The report actually generates a dataset, or you can go down to, if you go to develop, you can collapse all these, and you can go to the Power BI section and click on the Power BI datasets. If you click on the Power BI datasets, you would see that on the right-hand side, you have the option to create a new Power BI dataset. So we're going to click on that. And it's going to prompt us to, hey, if you don't have Power BI Desktop, install it now. If not, let's start the process. First thing is, what data source do you want to create? So you can see, you already prompt us with the data sets that are available. In this case, SQL Pool 01 that we're going to use. Continue. And it creates that connection for us, the connection string between our Power BI Desktop file we're gonna download and the SQL Pool 01 database. We're gonna click on download. And when we download, it gives us a Power BI DS or dataset file. If you have Power BI Desktop installed, it's going to open it in Power BI Desktop. All right. And let me show you what's happening behind the scenes, because it opened it in another window here for me. All right. So it opened Power BI Desktop, and it automatically opened up the data set for me. I'm going to do it again so that you can see what happens. This might be a little bit different for you because you may not be already signed into Power BI Desktop, which I already had. So it might give you an authentication screen. If it does, the easiest way, well, you have to go to your lab environment, again, the section up here, and you're gonna need to log in with your credentials with Power BI and be able to authenticate with Power BI and your Synapse Analytics environment with your credentials. Once you do that, we're going to select a table called the Worldwide Importers Fact Sale. So we're just gonna click on that table, and we should see a preview of that table here. We can expand if you want to see a little bit more, and then we're gonna click load. So once we load that file, that data set, or the connection is going, or that table, sorry, it's going to ask us, do we want to import this into the Power BI dataset cache, or do we want to connect to this dataset using direct query? In our case, we're going to use direct query, which means we're going to query the data directly, the data source directly, whenever we want to pull data from Synapse, instead of importing it and then using Power BI's cache. And you can read a little bit more about Power BI direct query mode in that link that's there, or you can search it and look at the documentation, how it works, and the use cases. So now we have essentially a Power BI dataset file that we can publish into the Power BI service. For this step, if you haven't signed in, make sure that you're signed in with your lab credentials so that you are able to publish to the Power BI workspace in your lab environment credentials. So I'm going to click publish, which is up here. I'm going to have to save it, of course, and let's call this the WWI, what's it called? Fact sales is what the instruction. WWI fact sales, and I think I already have one, but it's going to override it. That's fine. And in this case, I'm going to publish it to this workspace called that aligns with my lab environment. So I'm going to click select, and it's going to publish to the Power BI workspace in the Power BI service. For those of you familiarized with Power BI, if you click on this link, it will direct you, or you can log into powerbi.com or app.powerbi.com, and it will show you all the workspaces that user has available. So if I look at my workspaces, I only have that workspace available. And in that workspace, I can see the data sets that were created in that workspace. In this case, it's both a report and a data set, but what we're interested is in the data set. Now, an important step to every data set that you publish is to specify the credentials that the service needs to use to connect to the source. In order to do that, we're going to click on this, I guess they call it the hamburger buttons. Looks like a hamburger, I guess. Click on that, and you should be able to go to settings. And under settings, you should see that data source credentials. In my case, because I had already added my credentials, I guess it's stored. If not, you will need to edit those credentials and change it to an OAuth 2 and sign in. And what that will do is essentially will grab the current credentials, it's going to encrypt them, and use those to impersonate you as the connection user or principal to connect to the data source. In real world scenarios, you might have a dedicated service principal, master account, whatever you call it. To do that, that's not tied to a user. That's a whole other conversation, but just keep in mind that you need to specify those data source credentials. Now that you have specified those data source credentials, we can go back and we should see that data set here. If you don't see it, make sure to click on the ellipsis and click on refresh. And now we should see that Power BI data sets here. We should see the report because every time you publish a data set, a report gets populated. So that's why you see that here. But we're going to work today with the Power BI dataset. So your Power BI assets, that workspace that you defined in your Power BI environment, integrated directly into Azure Synapse. And now you can access those datasets which in turn are connected to the data that's defined in Synapse, and be able to quickly create visualizations and reports out of them. So we're going to click on that Power BI datasets, and on the right-hand side, you'll see that dataset, and you'll see this icon that allows you to essentially create a new report. So let's click on that. And what opens up is the development environment, similar as the one you get in Power BI Desktop, but now in the web. So now you're authoring, visualizing reports in the web as well. Everything self-contained, seamless integration, no need for additional tools, installations, everything is now self-contained. So the next thing we're gonna do is we're gonna create a chart. In this case, it will be a column chart with a line cluster chart. So now we have a placeholder, we're gonna make it bigger. And you see that that chart now has different axes and different series and values that we need to provide. So in the shared axis, we're gonna use the salesperson key, and we can drag it there. For the column values, we're gonna use the total excluding tax. So column values in there. And in our line values, we're gonna use the profit. So now that we do that, you can see that you're gonna see the little spinning progress right here, but it is actually executing a query against our Synapse database in bringing that data back. Now, in addition to that, we can add some filtering. So for example, I want to see only records where the profit was greater than 50 million. So 50, 1, 2, 3, 1, 2, 3, and we can apply the filter. Once I click the apply filter, it's gonna send that query back with essentially like a where clause where profit is greater than 50 million. So I'm gonna click on that, and you can see the little spinning, and boom, it returns that data back. Now, all of this is returned in sub-second execution times, because this is not data that has been imported into the cache that then Power BI has to filter. It is actually connecting to 29 million plus records, or more than that, 12 million records actually. And it is sending that query directly to Azure Synapse, to that SQL pool that's hosting the database, executing a query with a where clause, which is filtering the data at the source, and then bringing that filter data into the Power BI dataset. And that's why direct query is so important, because it allows you to aggregate and query vast amounts of data without hitting performance or limitations or performance issues in Power BI itself. You can query the data directly from the source and just bring the results back in a nice graph. So that is essentially the lab on Power BI. The last thing I wanted to show you, which as part of the lab, which is really interesting, is that query that that Power BI just executed. If we go to the monitor section and we go to the SQL requests, one of these requests, and maybe we can expand this a little bit. Let's see, one of these requests has the query that Power BI executed. Let's see, submit time, let's see, 457, 459. So it should be this one, I think. No, oh, it should be the last one. No. Let's see, you should see one with a coalesce or a filter by. Let's see. Okay, maybe it just hasn't been logged. Should be this one. Okay, it has not been logged, I guess. Let me just do another refresh. Last Eastern time. Yeah. I don't see it. Oh, interesting. Okay, so it's still not showing up. Sometimes it takes some time for it to show up. Okay, But as you can see, what you would expect to see is a query that's logged, similar to this, where it's bringing the data, aggregating it by profit, and then bringing records where the profit is greater or equal to 50 million. So that should be monitored at any point here. Not there. Okay. So that is all the time we have now for the labs. The last lab that we're not going to be able to get to is the data modeling. That's an optional lab, which typically, unless you go fast, you don't get to it. But there's also some issues with the lab itself. But you can find that lab in the create a sample data model in an exercise 5, essentially, here. And essentially, the lab, what they wanted to show you is that you can select a model that is stored as a binary or a hexadecimal format, or var binary format, into a table. So essentially, the use case or the flow will be your data scientist create a model that he or she stores in a table with all the list of models. You select that model from that table, and that model is stored as a var binary, essentially like a big, string, hexadecimal string that it's has been hashed. And then what you do is you select that model, and then you execute a query similar to this, which you're executing the data that you're passing to the model. So this is the data section. In this case, it's passing the WWI sample data table. It's passing it to the model that's being selected here. And it is getting back the prediction from that model as a value, as a column called prediction. And it's selecting those two data sets, the original data that was passed to the model, and then the prediction values coming out of the model, and then being able to display those results side by side in a table. And in essence, what you will see returned, if you look at the lab 5, lab 6, is essentially your original table. And in this case, a table only has one row, and the prediction. And this is essentially a model that predicts the number or the amount of products that a particular customer will buy from you. So it just shows you how easy it is to make use of a model and pass the data seamlessly all within your environment. And to the user, what it looks like is just essentially like a SQL query with a special function called predict that you issue or you execute in your Azure Synapse development environment. So with that said, that concludes our workshop today. I appreciate your attention to the lab, and to the presentation today. We have, I think, 8 more minutes, so this is supposed to run until 3:30. So we have about 10 more minutes to any questions that you might have. So feel free to add them into the Q&A section, or feel free to contact me. We're going to send out probably an email afterwards with a link to the recording. And also, with my contact information, if you need to contact me, I will be more than happy to spend some time with you. And I encourage you to look at the documentation for Azure Synapse Analytics from the Microsoft site. I also encourage you to go to our website at www.agilethought.com and look at our events section. We have upcoming workshops similar to this one, Analytics in a Day. We also have AI in a Day, and some other workshops that you might find valuable, as well as the Accelerate Summit that you see that I'm promoting here, that you will find valuable for in many topics that we're going to be covering there. And then lastly, I also encourage you to visit some of the offerings and services that we have online. such as the Power BI Ignite, if you already started with your Power BI Ignite, Power BI journey, as well as some cloud migration and data analytics migration and offerings that we offer to our customers. So again, thank you again for joining us, and I hope you found this valuable. Feel free to reach out via email, via LinkedIn. You can find me at jose.chinchilla in LinkedIn. And I hope to talk to you at some point soon. So thank you very much, and we'll conclude the workshop now. Thank you.